Okay, I think we'll kick things off now. Good afternoon, everyone, and welcome back to our webinar series, Zero Trust 101. I'm Nick Jacob from Identity Methods, and I'm joined again by my colleague Alan Fennick from Color Tokens, our Zero Trust partner. For those joining for the first time and for those rejoining from last week, what we went through there was the NIST principles of Zero Trust, which were kind of rounded off with the 6 recommended steps, the first of which was about visualization, which is what we're going to talk to you about today. We can't protect what we can't see, and traditionally the focus was always on external threats coming into the organization and how we monitor that. In other words, north-south traffic. The net recommendations laid out by NIST and Color Tokens were instrumental in helping NIST arrive at those standards, featured the critical element on how we achieve true visualization, which is also about lateral movement and east-west traffic. Gartner point to the fact that 80% of data traffic flows are internal, and yet only 10% of that is being monitored. So hopefully today you'll walk away with an idea about how that 360-degree view is achieved. And Alan will run through those concepts with you and a very brief demo on what that might look like. So at this point, I'll hand you over to Alan to talk about visualization. Over to you, Alan.
Thank you, Nick, and welcome everyone to the second part of this series. Today, I wanted to just quickly recap on some of the points that Nick has just highlighted about the importance of being able to visualize your network and understand what particular traffic flows and activities are happening on a daily basis or a regular basis within your infrastructure. So in terms of dependencies and interactions, it's quite important that we are able to map these things out. If we want to know exactly who is accessing what, we need to really understand, basically, are they a known good connection, or are they potentially exposed to traffic conditions or access that is unnecessary for their particular function or an application's function? With a view for that, if we recall what the ultimate goal of this is, it's to make the policies that we create more dynamic and more granular. More granular means that we want to move the important point as close as possible to the actual network device or workload. So with that, that helps us achieve an ultimate goal of preventing lateral movement should an organization get themselves into a situation where they are breached. And it also helps us get much more granular understanding of exactly what is happening on a second-by-second daily basis within our network infrastructure. So that's just a recap of the principles that we're trying to achieve. So with visualization, what does that mean? Why is it important? Well, really, we need to be able to produce somehow a real-time map of your assets and workloads. So if I speak to most organizations, they have some degree of understanding or a good degree of what they actually have inside their network. You can probably tell me how many servers you have. You can probably tell me how many applications you have to own. But to actually gain visibility, rather than having to do audit reports or very, slow and non-graphical representations of how things talk to each other, the new world really needs to point towards something that gives you that graphical representation rather than just lines of firewall code that you have to access and understand whether they have hits against them, whether they're valid anymore. It becomes very difficult to achieve without implementing some form of map. So we also want to understand the potential exposure of those workloads. We need to understand how they communicate with each other, what ports and processes they're using. And equally, we need to understand if we have open access from certain workloads to, for instance, the internet or external networks, the ability to monitor in real time and get that view and visualization is key to be able to develop some form of new security strategy based around zero trust. So with that, I want to talk a little bit about a possible way that you could deploy color tokens and give you some examples of how we've approached this problem and how the architectural layout works. So firstly, on the left-hand side, we have agents that we can deploy out to your workloads in your infrastructure. And what I mean by an agent is a very lightweight antenna that communicates with the rest of our infrastructure. We have something called Color Master Tokens Instance. Now that basically is a SaaS-based tenant that we provide to nominated customers to be able to have their own individual view of their world, and it's completely customizable. The agents can be deployed either on-prem, they can be deployed into your cloud infrastructure. We support a multitude of operating systems and environments. So regardless of where your infrastructure lives, the agent will follow that particular workload and your application regardless of its location. So once we've built this map, we can then go about potentially creating policies and rule sets to start to go about enforcing microsegmentation, which we'll talk about in next week's session in more detail. So with that, I'm just going to flip over now and start to give you a real-time demonstration of what we actually can provide and give you a viewpoint on what visualization can do. So this screen, when we first log into Color Master or the Color Tokens instance, we can see various different assets that have been registered within our system. Like I said, we cover a multitude of operating systems, and what we're doing is gathering telemetry information from those devices. So if I click into one of these, we can start to see some more advanced information about what this workload is doing. So I can see things like its operating system type, I can see what type of CPUs it's running. I can also see the utilization of the agent that we've deployed. Now, typically, this is very, very low usage. It barely registers on most counts in terms of memory usage is very low, typically no more than around 20 to 30 megabytes of usage. And CPU is very minimal as well. And this is quite important because agents traditionally have been quite resource hungry, whereas we've taken the approach to make sure that that's extremely lightweight and doesn't interfere with any of the operation that that particular workload is meant to be doing. So we can see, obviously, the agent version that's out there, but more importantly, we can actually see what interfaces are running on the system. So for instance, here we have an internal IP address that's running on this particular box, and that allows us to start to gather and understand exactly how these devices are talking to each other. The next portion I want to show you is something called tags. In a traditional world, when we're starting to look at exploring policies from firewalls, we're doing that based on IP addresses. Now, IP addresses are necessary because they're the core of how computers talk to each other, but fundamentally, they're very difficult sometimes to make sense of and are hard to audit. And what we've taken an approach is the notion of tags. So we can tag workloads with more relevant information in natural language that actually makes sense when you write policy. So an example set of tags here is, what application is this? Does this workload belong to? In this instance, it's SharePoint. What environment does it belong to? Is it a production? Is it a test system? Is it a development system? What is its location? So geographically, where is it located? Is it one of your own private data centers in a certain city? Or is it potentially a cloud instance? It could be AWS or Azure, for example. And also, what role does that particular workload have? Is it a web server? Is it an app server? Is it a SQL server? So once we've defined all of these tags, it allows us to make a map that actually makes sense to a user when they log into it. We can equally do things like look at what vulnerabilities are resident on that particular host. So a lot of customers have vulnerability assessment tools. We can port that data in and start to also visualize which hosts have potential vulnerabilities that haven't yet been patched. If I move on now to what we call the dashboard, we can give you a heads-up display. This heads-up display is examining all of your deployment, giving you information about traffic patterns, how many connections are happening, potentially if there's any bad reputation IP addresses from the external world attempting to access your infrastructure. And as Nick was saying earlier, the predominant amount of traffic that's happening inside an organization isn't necessarily from the outside world on the perimeter. It's traffic that's happening internally. So we need to be able to visualize what that traffic looks like. I'm going to move on now to what we call the visualizer. The visualizer is almost like a Google Earth style representation of exactly what is talking to what within your network. So we can zoom in and out, and we can start to drill down into particular groups and gain more understanding of how your network is laid out and how applications are communicating. So for example, here we have a PCI environment, we have an ERP environment, we have a CRM environment, and all of these things to some degree are probably communicating with each other. But how do we understand exactly what traffic is flowing between them? As we continue to drill down into these, we can actually start to filter and take a look at an example of what communication flows are being allowed or disallowed. At this point in time, we're just making a map. We're not going to be enforcing policy. We're just observing what is happening inside your network. So if we look at the legend here, we can take a view of what exactly all of these lines mean in colors. So for example, the green lines represent permitted traffic, the red lines represent denied traffic, and the orange lines represent effectively some traffic that's allowed and some traffic that is disallowed. If we click into these, we can start to see what that connection attribute looks like. So from here, we can see that this app server group is communicating over TCP 443, and that's an authorized connection. So it's using some form of SSL connection to the outside world. However, if we take a look at, for instance, one of these red lines here, we start to see that for some reason, a private managed device is trying to access that service over 27017, which is actually a denied, unauthorized path. So we start to build out this visualization, this map, depending on how large your infrastructure is. Some people will start to deploy this map on a very small scale. As you grow and understand where you want to protect potentially devices, this map can expand dynamically. And equally, if workloads were to move from one location to another, let's say you have a DR event where you want to move something, because this the policy will follow wherever that asset lays. And with that, I'd like to conclude today's session and hand back over to Nick, who will give you an outro.
Thanks, Alan. So I think what we covered off today was a key component and starting point when we look at zero trust both as a concept and also to help us build a zero trust architecture. Ultimately, it starts with visualization. We can't protect what we can't see. So what it allows us to do essentially, and just to recap, is it allows us to control access to workloads and stop lateral movement if it represents a threat to our critical assets. So visualization essentially does two things. It allows us to understand our assets, how they communicate with each other and how they communicate with the outside world. And ultimately, it allows us to understand our exposure to threats. And I think what Alan did here with the demo was to give us a graphical representation about how we gather that telemetry of operating systems within our estate, how we get summaries, tags, and vulnerabilities, and an overarching view with a dashboard there as well. Of course, the other key aspect to all of this in protecting workloads will be covered off in next week's session when we look at segmentation. So on behalf of Alan and myself, we look forward to seeing you all again next week. Enjoy your weekend. Thank you.